The debate over free will has raged for millennia, usually confined to the realms of philosophy and theology. But as we peer into the subatomic architecture of the universe, the question of choice is moving from the abstract into the empirical. We are entering an era where we can begin to discuss the physics of choice. In a classical Newtonian universe, free will is an illusion. If the universe is a giant clockwork machine, then every action, every thought, and every choice you make is simply the result of a chain of causality stretching back to the beginning of time. If we knew the position and momentum of every particle in the universe, we could theoretically predict your entire life with absolute certainty. This is biological determinism, and it leaves no room for the self to steer the ship. But the quantum world is not a clock. It is a probability field. The foundation of the physics of choice lies in the principle of indeterminacy. According to the Heisenberg Uncertainty Principle, it is fundamentally impossible to know both the position and the velocity of a particle at the same time. This isn't a limitation of our sensors, it is a fundamental property of reality. At the subatomic level, the universe is not made of certainties but of possibilities. When a particle is in a state of superposition, it hasn't chosen its path yet. It is the act of observation, the interaction with the environment, that causes the wave function to collapse into a single definite state. For decades, physicists have debated what role the conscious observer plays in this collapse. If the mind is a quantum system, then the act of making a choice could be the biological equivalent of a wave function collapse. To understand how this might function in the brain, we have to look at the scale of neural activity. For a long time, neuroscientists believed that the brain was too warm and wet for quantum effects to survive. They argued that decoherence would destroy any quantum states before they could influence a neuron. But new research into quantum biology suggests that nature has found ways to maintain coherence in biological systems, such as in the way birds navigate or how plants perform photosynthesis. If the synapses in our brains operate at a sensitivity level where quantum fluctuations can trigger a signal, then our thoughts are not just the result of chemical reactions, they are the result of quantum events. This would mean that the brain is not a classical computer but a quantum transducer, turning subatomic possibilities into macroscopic actions. This leads us to the concept of agentic collapse. If our choices are the result of quantum events, then the self is the observer that collapses the wave function of the mind. This gives us a physical framework for free will that doesn't violate the laws of physics. It suggests that while the past is fixed, the future is a field of multiple potential outcomes, and the observer, the consciousness, possesses the agency to select which outcome becomes reality. In a military or strategic context, this is a profound realization. It moves us away from linear game theory, where we assume the enemy will always make the rational or determined move, and toward quantum strategic thinking. It recognizes that a high-stakes decision maker can effectively will a reality into existence by collapsing a probability cloud that others didn't even see. However, the physics of choice also introduces the concept of entangled will. If our brains are quantum systems, they can be entangled with other systems, other people, our environment, and even the machines we build. This means that our choices are never made in total isolation. We are part of a larger collective wave function. In an age of high-frequency social media and pervasive AI, our individual will is constantly being interfered with by external signals. These signals can cause a preemptive collapse, where our choices are made for us by the architecture of the information we consume. For a technology leader or a founder, the goal is to protect the quantum potential of the individual. We must build systems that allow for the maintenance of superposition, the space where true innovation and original choice happen, before the environment forces a collapse. As we move forward, the physics of choice will redefine our legal systems, our ethics, and our technology. If choice is a physical event, then the freedom of thought is a matter of protecting our neurocoherence. We are moving toward a world where the ultimate high ground is the sovereignty of the individual wave function. We are realizing that we are not just characters in a pre-written script. We are the writers, using the subatomic tools of the universe to carve a path through an infinite field of possibilities. The question is no longer whether we have a choice, but whether we have the courage to maintain our superposition long enough to find a path that others haven't seen yet. The future isn't something that happens to you. It is something you collapse into being.